Well, hello everyone. In this lesson, we will look at operations on functions. We have been using many of these ideas all along, but now we will give them specific names. For instance, if we had a function a of x equals x squared, b of x was x cubed, c of x equals x fourth, and suppose d of x equals 5x squared plus 3x cubed plus 2x fourth, we can say that d of x is equal to 5 times a of x plus 3 times b of x plus 2 times c of x. Thus, we can make new functions by operating on old functions. We use special notation for this. So, given functions f and g, the functions, in this case the new functions f plus g, f minus g, f times g, and f over g are defined by f plus g of x equals f of x plus g of x. F minus g of x equals f of x minus g of x. F times g of x equals f of x times g of x, and f over g of x equals f of x over g of x, provided g of x not equal to 0. The domains of the new functions are real numbers. Let's look at a couple of examples. If f of x equals x plus 5 and g of x equals root x, find new functions and write the domains in interval notation. First of all, a, f of x plus g of x. The new function for this will be f plus g of x. And f plus g of x is equal to f of x plus g of x. And so we plug in for f of x and g of x, that would be x plus 5 plus root x. Now, the domains in interval notation, the domains are the interval or the intersection of the old functions, the intersections of the original functions, right? That would be the intersection of f of x and g of x. So we know f of x, the domain was negative infinity to positive infinity, and g of x was 0 to positive infinity, so they intersect at 0 to positive infinity, right? And the intersection would be bracket 0, comma, infinity, parentheses. Okay. Part B, f of x minus g of x. The new function is f minus g of x, and that is f of x minus g of x. And so that will become x plus 5 minus root x. Again, the domain is the intersection of the functions. So your domain here will be, again, 0 to positive infinity. So bracket 0, comma, positive infinity, parentheses. Part C, f of x times g of x, which will be f times g of x, being our new function, equals f of x times g of x. And that will be x plus 5 all times radical x. And if we want to expand that a bit to be equal to x radical x plus 5 radical x, and again the domain will be 0 to positive infinity. That's the intersection of the two original domains. Part D, we have f of x over g of x, which is f over g of x, which is our new function. Provided that g of x is not equal to 0, then we will have an output for this function. It will be x plus 5 over radical x. Now note here is that The restrictions here will be that because it's in the denominator, radical x cannot be equal to 0, and also radical x must be greater than or equal to 0 because of the square root function. So in this case, x is not equal to 0, and x must be greater than or equal to 0. So if you combine these, it would be that x must be strictly greater than 0. So your domain will be parentheses 0, infinity, parentheses. Right? And so that is it for your intervals. Now, let's talk about composition of functions. Suppose we could compose functions one with another. That means we can make one function of another function. If we compose a function f of x with another function g of x, we can make a composition called f of the g of x, denoted parentheses f with a little o, and the g parentheses of x, or parentheses f parentheses g parentheses of x. So that's two ways of writing f of g of x. The other way we can compose them is that we can compose the g of the f of x, we'll talk about later, or we could do g o f, or some people have called that gov x. So that's another way. So this is another way. That's way 2, g parentheses f parentheses of x. So this is another way of writing gov x. It's another way of writing what some people call fog x. Let's look at an example. The example is, let f of x again be x plus 5, g of x is equal to root x. So we're going to compose one function into the other. So f of g of x, or f g of x, so fog x, people might want to call it fog x, equals f of the g of x. That means g of x is what we call our inside function. Inside, that means we plug g of x, whatever we had for g of x, which will be our x, so that would be the f of radical x. And the f of x was x plus 5. So wherever you see x in your f function, you replace that with your input, which is radical x. So that is going to be radical x plus 5. Right? So this radical x plus 5 is our f of the g of x. Right? And now let us look at the g of the f of x. So part B, well, g of f of x is equal to g parentheses f of x. F of x now is your input, so we replace this f of x here with x plus 5, so that's going to be the g of x plus 5. And the g function is a square root function of x, so that would be the square root of all of x plus 5. Notice f of g of x and the g of f of x are a little bit different, in that with the f of g of x is just a square root over the x, and plus 5 is outside. But the g of the f of x, the radical is over both the x and the 5. In terms of domains, the f of g of x, the domain will be 0 to infinity, where 0 is included. And in terms of g of f of x, the domain would be -5 to infinity. Right? The -5 is included. Okay, now let's talk about evaluating a composition of functions. Evaluating composition of functions. Now, evaluating composition of functions, let's say f of x, again, was x plus 5 and g of x was radical x. What we want to do then is that we want to plug in find the composition of functions first and then plug in your 9. So let's find the composition of functions. F of the g of x, which we found out earlier, but let's do it one more time, will be the f of radical x, and that will be radical x plus 5. And now, so what we want to do is find f of the g of 9, which means you plug in 9 for x here, so that's going to be radical 9 plus 5, which will be 3 plus 5 equals 8. Then part B, we want to find the g of the f of 4. We already found the g of f using the same equations before, but let's take another shot at it again. It's going to be the g of f of the g of x. Let's do x first. G of the f of x is going to be the g of x plus 5, which will be radical of all x plus 5. And then we plug in 4, so g of the f of 4 now will be equal to radical of 4 plus 5 equals radical 9, and that will be equal to 3. So that is your answer for evaluating the composition of functions. All right, let's talk about difference quotient. Let's talk about difference quotient. Now, with a difference quotient, our ideas are similar to what we had with average rate of change. Remember when we had average rate of change, it was f of x2 minus f of x1 over x sub 2 minus x sub 1. Imagine now that our x sub 2 was x plus h and x sub 1 was just x. What would happen to the original average rate of change formula? We can rewrite the slope of the secant line as delta f of x over delta x is equal to f of x plus h, which x plus h replaced our x sub 2, and then minus f of x, which replaced our x sub 1, over x plus h minus x. And so that gives us f of x sub h minus f of x over h. So very, very, very simple formula here now that we have h under the bottom, and then f of x plus h minus f of x at the top. So that is our difference quotient formula, which is f of x plus h minus f of x over h. Let's look at a real quick example. Find the difference quotient for f of x equals 3x squared. So difference quotient is always this formula, f of x plus h minus f of x over h. All right, so let's recall f of x was 3x squared. So f of x plus h would be equal to 3. Replace x with x plus h. That's going to be 3x plus h all squared. And so that's going to be 3. Expand the x plus h squared. That's going to be x squared plus 2xh plus h squared. And then simplify this a little bit more, becomes 3x squared plus 6xh plus 3h squared. Now plug these into the formula. We'll have 3x squared plus 6xh plus 3h squared all over h. And we can factor this. Oh, we have to, before we do that, we have to subtract our 3x squared before we actually do any factoring. So this 3x squared subtracted from this 3x squared will drop out. So we have 6xh plus 3h squared over h. And then we can now factor out an h from the numerator. And then that becomes 6x plus 3. And then over h. So our answer